let me start from the point which we have stopped last time, and we have had one class, right? The introduction class we already had, right? Yes or no?
Yes, sir.
We had our introductory class, and now today we are going to start with this computer graphics system description. So we discussed about computer graphic applications last time. As we discussed that we are going to cover more application parts here. The practical parts are also there. At the beginning, I told you that you have to install maybe computer the Adobe Photoshop or CorelDRAW, those type of software. I think most of you have done it, and even though you have not done it in your uh, previous study, the diploma or the A levels, we are going to cover some of those things here, but we are not going to do the evaluation on those things. But we will do some kind of understanding or conceptual understanding through those software. And when we go to the other part, that is the 3D graphics, we are going to discuss about 3D graphic creation with the different operations, right? So when we look at the computer graphic system can be divided into two categories: computer hardware and computer software, right? Computer hardware and computer software. So the computer hardware normally give the that means fundamental uh, elements to produce the computer graphics. Now the devices are there, like display devices and the card type of processing devices are available there. So the graphic card, display devices, output devices are available there. When you come to the computer graphics software, those are the calculating elements. Most of the time, creation of computer graphic elements and the data for the display and the storing, all these things are done by the software. So that includes computer graphic drivers and programming languages. Now, apart from that, you have applications, computer graphic applications, any use application which use on graphic hardware and software we call as applications. Now, when we come to the basic graphic system, when we take the computer graphic system, the basic graphic system consists of input devices and also processing devices and output devices are there. Now let's see what are the devices, main devices available, and what are their operations. ඒවා එක එක කෑලි වල තියෙනවා එක එක කරන කාර්යයන්. ඒ කාර්යයන් මොනවද? ඒ කෑලි මොනවද කියලා අපි බේසික් කෑලි ටික තමයි බලන්නේ. So when we look at the input devices, we can have the graphic input device as mouse, keyboard, and also tablets, and also you can have drawing tablets or the pads. So drawing pads, all these things can be taken as input devices, graphic input devices, where you type something, it goes to the display device. So when you draw something on the tablet, it goes to the display device. And when you have a mouse input and movement, and that will go to the output device. And then those things will be processed here. So the processor is available to process those things. So the processor process it and put it into the memory, and from the memory it will form into the image buffer, right? It will form into the image buffer and it will go to the output device. That is how it goes here. And now this frame buffer holds holds the data, whichever the thing we want to hold and display, right? The frame buffer will hold that data, whichever the thing we want to hold and display, and the processor takes the inputs and transfer that into the frame buffer. Let me talk about this frame buffer. What is it? Now, frame buffer is a kind of a temporary storage, which keeps what are the things available on the display. We know that any display device which is called as a digital display device contains number of dots. Those dots we called as pixels. Normally in the digital display device, when we consider digital display device, fundamental building block of digital display device is taken as pixel. Now for each and every pixel, there is some information to be displayed, that means a color. So that data is to be represented or stored within some kind of a memory. That data is to be stored within some kind of a memory. So that data we store in a frame buffer type of memory. Frame buffer type of memory. Right? That's how it goes. Now when we consider about this frame buffer, the frame buffer takes some data, right? Some data from the input devices and pass it, whatever the thing you want to display on the screen, and keep it on the memory. From memory, pixel by pixel data will be taken into the display processing. Now here, these input devices give some kind of input, and that the data will be processed here. The input data coming through these input devices will be processed by this particular processing, and together with the memory, and then that data transform into the frame buffer. That data will be transformed into the frame buffer, and the frame buffer then store that data temporarily. Right? Frame buffer store that data temporarily, and that data we called as a kind of image which is formed in the frame buffer. That data we called as an image which is formed in a frame buffer. Right? So from that frame buffer then, that data will be transformed pixel by pixel data onto the screen. The pixel by pixel data will be transformed onto the screen. So here in the frame buffer, there are some memory locations which corresponds to different locations on the pixel plane. Different locations on the pixel plane. Right? So this data available in the frame buffer transform into the display device and display that data whatever you want. Now, therefore, you may think where this frame buffer is. Normally, frame buffer is store that data. Now, you know that the display, if you take a normal computer, from the normal computer, you are having a cable to the display device, right? VGA cable load, DVI cable load. There may be a kind of a HDMI cable. That may be HDMI cable or VGA cable. So that cable connecting to the display information available within the frame buffer. Then from the driver, it will transform what the information you have to send to the display that device. In a kind of a LCD device, you have locations. Or LED device, so you have LED display elements on the screen. So each and every element will get some kind of information about what is the color to be displayed on that particular LED. So that information will be given by this frame buffer. So the frame buffer task is to hold pixel by pixel data for one frame. One frame means one screen. One screen, one particular time. Now there is another situation that is about video. Now I'm talking about this particular diagram a little bit because you have to understand what it is. Now when the video is going on, the videos consist with many frames. With 1 second, there are multiple frames are changing. Within 1 second, there are multiple frames are changing. Right? That we called as a basic graphic system. Basic graphic system. So on the screen, you can see different number of frames are changing and moving. Right? Different number of frames are moving and changing. In such situation, you can clearly see that uh, a particular situation, that data has to be transformed into the display device, and now new frame has to occupy the frame buffer. Always new frame has to be occupied in the frame buffer. Now the frame buffer is not a big one, big memory. Frame buffer is not a big memory to hold many pictures together. Because here in the frame buffer, you are not going to have any compressed data. මෙතන compressed data නෙවෙයි අපි frame buffer එක ගන්නෙ නිකන් දිගෑරපු data තියෙන්නේ. Right? It is unwrapped data and raw data available for the pixel by pixel information. Right? So this frame buffer memory is not a big one. Therefore, sometimes in the the graphic memory you can keep few frames. Other frames are to be stored within the graphic card memory or somewhere else. Graphic card memory or somewhere else. Therefore, the graphic memory and the frame buffer has to work very faster manner in the exchange in exchanging the data. Right? Therefore, graphic memory and the frame buffer has to work very faster manner in this situation. Right? In this situation. So the frame buffer changes its data quickly. Right? Frame buffer changes its data very quickly. And then when the frame buffer changes its data, right? When the frame buffer changes its data, that means already you have to pass that particular frame to the screen. Then only you can occupy with a new frame in the frame buffer. So therefore, you have to understand this frame buffer holds a kind of a smaller frame, smaller one frame. Right? Data belongs to one frame. Now this one, the processor. This processor is not the central processor always. Always that is not a central processor. Now central processor has a lot of tasks to be done. If there is no any separate graphic processor, right? Nowadays in the most of the processors like i3, i7, i5 processors, i9 processors, you have inbuilt Intel graphic processor adapter, HD graphic adapter. Intel HD graphic processor is there. That processor is a separate processor to the central processor within the same processing unit. Right? If you look at the specification of processor, you can see that processor cores and everything available. And apart from that, you have a HD graphic, Intel HD graphic processor. So that contains the graphical processing instructions. So that one, now in that case, you have to understand nowadays the processor has taken that graphical processing part out from the normal processing. Right? And that graphical processing is done by this particular small processor. When you have a video card or GPU card, nowadays we are using that as a GPU, graphical processing unit, GPU. I'll write it here because I don't have a board to write here. GPUs are their graphical processing unit. When you consider about the graphical processing unit, the GPU or that card has a separate processor to process this graphical data or graphical elements, and the graphical processing is done by this GPU. Right? Therefore, this graphical processing unit or GPU takes the data from the graphical memory and process that data and pass it to the frame buffer. In the normal processor, HD, Intel, HD, or whatever the graphical unit available within the normal processor also provide that facility, passing that data from memory to the frame buffer. Because the memory only, you can keep a lot of data coming as input, so keep the data for the display device. Right? So here we have learned few things. One is frame buffer concept. Frame buffer is a kind of a temporary memory we are keeping in between the display device and the processor, graphical processor or graphical card, the processor within the graphic card. And this graphical processor can be available within the central processor also as a separate part nowadays, HDD. Okay? Memory here represents, sometimes it may be main memory, or otherwise if you have a separate graphic card, that graphical memory. Nowadays, the graphical memory has to work very faster manner, not like others, because the graphic is smoothly changing, right? The videos are very nicely changing in the screen. Therefore, the number of pictures are to be presented on the screen within 1 second. There are a number of pictures to be shown on the screen for 1 second. So these things we have to understand properly. Now, these concepts we have learned how the graphical system works, right? This will give you some kind of understanding of how graphical system works. How this input to output this graphical data. Now, when you come to the computer graphic hardware, right? When you come to computer graphics hardware, so the computer graphic hardware devices can be classified into two groups. It can be classified into two groups. One is raster device, other one is vector devices. There are two categories, raster device category and the vector device category. Now, as far as I discussed last time also, there are two categories of graphical hardware and software both you can find. Now, come to hardware devices, we have the raster devices and vector devices. Now, how can we separate? What's the main feature to separate raster devices and vector devices? That is the main question. What's the difference between raster device and vector device? Same thing we can apply into the raster graphics and vector graphics. Another one can argue that the vector graphics are to display vector devices are to display vector graphics. Raster devices are for displaying raster graphics. That also someone can argue, right? So I am not going into that particular category of arguments now, right? I am not going to go into that category of arguments. What I'm going to do is actually I'm going to describe what are the main features of this raster devices and vector devices. In the raster devices, now let me discuss like this. Now you have a computer screen, no, even you have some kind of a mobile phone, right? Modern day mobile phone that has a screen, right? All of you, hello, hello, hello. I cannot hear your voices. Hello, no one is speaking. No.
Yes, sir.
Yes. So all of you have the screens, right?
Yes, sir.
In front of you. I don't know how many of you are using mobile computers. Some may be using mobile phones for accessing this one. Now tell me, out of you, out of all of you, how many of you are having raster display device? Raster display device in front of you. How many of you have raster display device?
Computer screen display and mobile phone display.
Computer. Now what I'm asking is, how many of you have raster graphic device in front of? How many of you are in front of a normal computer or laptop?
I'm
Normal
using
multimedia computer laptop? Huh?
I'm using the laptop.
You are using laptop.
Yeah.
What about others? Raise your hands if you are using laptop. You know how to raise your hand, right? Okay, there are many people using laptops. Only few are using mobile phones or something. I think all are laptops, right? Right. Is it a raster device or vector device?
I think raster device.
It is a raster device, right? Modern day computers are having almost all computers are having raster devices. First, thank you very much, and you can put your hands down now, or otherwise I can remove those things. Right. Now, device. How can you separate? I think the people who have done the diploma course should know about this thing, at least something, not the full detail, scientific manner,
Raster,
but yes.
raster graphics are pixel based, and
You are telling that raster graphics over which one?
raster graphics.
Raster graphics are pixel based. What do you mean by pixel based?
That means bitmap images.
Bitmap images are raster graphics, yes. Now, my question is, when you take a raster graphic, how it could be uh, now when you take a raster graphics, how it could be uh, take the pixel base or how do you know that is a pixel based or not? But what's the difference? What is the way it represent in the vector graphics then?
The zooming quality is good in raster graphics.
No, I am not asking about the graphics. I'm not asking about the hardware now. Here it's
De depend on resolution.
so you are telling that the device is now suppose that vector display device and the raster display device is there. Now, according to Dilshan's argument, the vector display device is not having pixels. Am I correct?
Yeah, it is based on lines and curves.
It is based on lines and curves. That lines are directly drawn or something, or maybe lines are available in that one. So there are no pixels, right? In Dilshani, according to your argument,
No,
then
there are, but mostly the raster graphics are pixel based.
mostly the, what do you mean by pixel based? Then you are telling that in the vector devices also pixels are there.
No, no, there are no pixels in vector
Ah,
device.
right. Okay, that's what I asked. Is a code. Now I'm not telling that whether it is correct or wrong, right? Dilshani's argument is that in the vector devices there are no pixels. Dots are not there, right? Okay. In the raster device, those dots are available or the pixels are available. Uh, how many of you agree with that one? Now you have to discuss, right? Normally, when I was doing this thing in face-to-face model, there are many questions I ask, right? And I will interact many times down here. I cannot do because I don't know where you are, and it's good you are talking, right? That's good. How many of you agree with Dilshani's argument? Viduranga? One is agreeing with Dilshani's argument. Who else? SK Karunaratna joins Dilshani's group. Anyone else? What about this Viduranga? You are not agreeing. Shishani, Viduranga, they are voting for Dilshani, right? Dilshani, who's that? Dilshani. Others are not voting, means against. Okay, now I don't want to ask anything from the people who have raised their hand. So keep your hands on. So let me ask other people. Okay, I will start from Akram. 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 Hello, Akram. You are wasting my time, Akram. So my tea is ready. You also can have tea because your video is not on, no? But I haven't had my tea. Right. Anyhow, Akram. What happened to this Akram? I think he has switched on this machine and went somewhere. Akram. Okay, let's go to the next one. Fatima Rikasa. Fatima Rikasa. Fatima. Fatima Rikasa. Hello. Fatima. So both Akram and Fatima Rikasa not responding.
Yes, sir.
Hello. Akram, yes, okay. Were you there when we were discussing about this? Akram. Hello.
Yes, sir.
Okay. Switch on your mic. Switch on your mic. Now, Dilshani told that the raster devices are built by using pixels, but vector devices are not having any pixel on the display screen. The vector devices are not having any display screen. You have not raised or you have not voted for her. Do you have any other argument? Do you have any other argument? Whether you have some other particular argument. So they have given some kind of argument though. Some people have voted for that argument. My question is, what is your argument? Do you have any new argument? Seems no, right? Seems there is no any argument. Fatima? Fatima? Now that some more people are joining that Dilshan is one. Pragati also. Pragati, Madhusha both raised their hand. Now they found now the questions are coming to them. Then when the questions are coming to them, they will raise hand. More people are raising their hands now. Gihan, Pragati, Madhusha, all the people are now raising their hands. Fatima, hello. Fatima.
Yes, sir.
Really, I don't have ideas.
There are two Fatimas, right? Okay, I asked Fatima Rikasa. Okay. Fatima Rikasa, hello. Yes. Do you agree with?
Really, I don't have any ideas, sir. Still, I'm searching.
You are searching on the Google. Right. Okay. Keep search. You will find. Listen to this thing, right? First, just participate in the class. Then later after that, you can search the things. Right. Next one is Hiruni. Hiruni. Hiruni Prabodha. Hiruni. Yes.
Sir, raster graphic pixel, but vector graphics, I haven't any idea.
Vector graphics, you don't have any idea. My question is now whether that vector graphics also got pixels or not.
I haven't any ideas.
You don't have any idea. Okay. Let's go to another one then. Navindu. Prakash. Navindu Prakash. Hello. Navindu Prakash. Navindu Prakash. He's typing. Don't have mic, sir. Okay. Now, why didn't you agree with that Dilshani? Why don't you agree with Dilshani? While he's typing, Rashida, can you switch on your mic? Rashida, can you switch on your mic?
Yes, sir.
Okay. Rashida, why don't you agree with Dilshani?
Because I have no idea, sir.
You don't have any idea. Okay. Are you from A levels?
Yes, sir.
Okay. Right. Drop down your hand. All of you can drop down your hands. Okay. Thank you for participation in the discussion. Right. These discussions are giving you more encouragement and you are learning things, right? Dilshani, can you switch on your mic?
Yes, sir.
Okay, Dilshani. Do you think that you are correct? Or do you think that you are wrong?
I think I'm correct.
You are thinking they are correct. That's why you told it, no? Right. Okay. I forgot. Right. So the thing is, we have to understand all the display devices or the digital display devices are built, the fundamental building block, I told it earlier. Fundamental building block of the display screen is coming from pixel. Vector devices or raster devices does not matter. Right? Okay, understood? Both type of devices are built by using pixel concept. Pixels are there. Is that clear now?
Yes, sir.
Yes.
Both devices are having pixels. Then what is the other question now? What is the other question? Then what's the difference, right? Don't you have that question?
Oh,
Hello?
milik
Don't you
check
have that question?
Yes, we have.
You have that question, right? Then what's the difference? There should be a difference between the vector raster. Okay. The way that display represent or draw on the devices. I'm taking output devices or display devices here now. Right? I'm taking output devices or display devices now here. Right? When I take these display devices, right? When I take these display devices, these pixels will fill total area in the raster devices. Total area means full screen will be filled with pixels. But in the raster display devices, only the shapes what we want to draw. If it is a line, only line, the pixels which are on the line will be drawn. Other things are dull, no illumination, no color. ඒ line එකේ හරි අපි අඳින shape එකෙන් එළියේ තැන්වල එයා define කරලා නැහැ මොනවද. You don't have any definition for the outside things other than the shape. Or the shape or whatever the thing you are going. It may be dot or maybe some kind of a curve or line or whatever the thing, or filled a circle, whatever the vector. It will describe only the area which has been described. Other parts are dull, no display. Okay? Other parts are dull and no display. Now, when we come to the raster devices, that is not the case. In the raster devices or the raster graphics devices, the full screen, the full total screen will be taken into consideration, and each and every pixel will be represented and shown. Each and every pixel will be represented and shown. Right? So understand this one. In the raster display devices, your screen is a raster display device. You can see all the pixels are having some kind of a color. From top to bottom, left to right, all the places you have pixels. Right? From top to bottom, left to right, all the places you have pixels. But in vector display, the pixels are there. When you draw the things, only the defined parts will be drawn, other parts will not be considered. Those pixels are off, not elimination is not there, not giving the colors. Right? That's how you can have these raster devices and vector devices. That's the main difference. That's the main difference. Now, the other thing is, when we consider about the raster device has to show all the pixels all the time. Therefore, from frame by frame or picture by picture, you have to get the pixel by pixel data and display on the screen. When you are working with raster device, from the frame by frame situation, for each and every frame, the pixel by pixel you have to display. You have to go through pixel by pixel and display. Vector devices, that is not the case. Now here we know that the arrangement. If you, in the frame buffer or some kind of a memory, if the frame is described with pixel by pixel color levels, you take each and every pixel, the corresponding memory location and the pixel location is there. Corresponding memory location of the data and the pixel location is there. You show that color on the screen. That is how it works. Right? When you go to the vector device, in vector devices, that situation is different. The vector devices situation is different. In the vector devices, at the moment you want to draw it, that processor, the graphic processor has to calculate what are the pixels to be drawn. That we call as intelligent processing is to be there. At that moment, that calculations are to be done. What are the pixels to be drawn? Maybe it's a line, it's a curve, or maybe any other thing. Right? So that particular processor has to calculate. I think you have seen that processor also earlier. This processor has to calculate what are the pixels to be drawn. And then that calculated or identified pixels will be drawn on the screen, and the illumination will be, that is, lightened. Those pixels will be lightened, other pixels are not lightened. That's what's happening in the vector device. So that difference also there. So dynamically, the things to be drawn on the screen has to be calculated on these type of devices in the card. But when you go to the raster device display, there is no such big calculations, only the picture information comes there. Pixel by pixel you have to upload to the screen. That's what you have to do. Row by row you have to do. There are multiple rows available, pixel rows available. Each and every row you have to do. That is how it happened in the raster graphics display. Now, that is the major difference between the raster and the vector. If you look at the printers, raster printers and vector printers are there. Do you know what is vector printer? Now, the normal printers, you know that laser printer, it's a kind of a raster printer. What is a vector printer? Prototype of things are vector printers. Those are vector devices. Only needed parts will be drawn. Other parts, lines and curves will be drawn. In those situations also, calculations are to be done, online processing has to be done, and then the goal. When we look at the hardware, there are some amazing changes are happening within this hardware nowadays. Fundamental architecture is shifting from one to another. Earlier we had this, the VGA card, Video Graphic Accelerator. VGA stands for Video Graphic Accelerator. Now AGP cards was there, Accelerated Graphic graphical processing, accelerated graphical processing cards. Now we have, now earlier the CPU, the central processing unit, also has done this type of calculations. In raster graphics also, certain calculations and the mapping has to be done. Scaling, those type of stuff. But yeah, no. So in such situation, those calculations are done by the GPU. GPU, what is this graphical processing unit? Earlier, VGA and graphical processing unit, what's the difference? Actually, it's a capacity difference. Earlier, when the graphical operations are done, the CPU also involved some way for the calculations and the operations. Now, when we come to the GPUs, CPU, central processor unit, or your processor, co-processor, take his hand totally off from the graphical devices, or graphical processing, display and video. CPU gives all the powers to the GPU. You do it. I'll take care. Right? අපේ අපිස් සමහරලාට කියන්නේ ඔයා වැඩේ කරන්න මම බලා ගන්න. Right? No matter in the modern computer, the GPU does all the processing and calculations and everything. Now, I don't know how many of you are the game fans. Are there game fans available here? Game ගහන කට්ටිය ඉන්නවද මෙතන? 3D games එහෙම ගහන කට්ටිය mainly there's one person. That is who's this? This is what's your name? Hello. Who's that? Prakash, okay. Are you using GPU? Are you using GPU? Huh? Yes, he's using GPU. Nowadays, the GPUs are coming with large processing power, but they can do a certain amount of operations. Not all the operations, some operations that GPU can do. So those operations will be done by the GPU. Normally, those operations will be done by the GPU. And those calculations, right? Those calculations are done by the GPU and process the things, right? Process the things. And so normally these GPUs do many operations for the display calculations and everything. Nowadays, therefore, the fans and everything comes with this GPU, and the big processing power is given for the GPU. And I will tell you something beyond these things. Now, the GPU computing is a separate way of computing we are doing for the high performance computing. Yeah, we can use that power for the processing as well, for the data processing and what we call many other situations. We are using GPU for this. Now, as I mentioned earlier, raster devices normally scan the whole output area in the raster fashion, scan the whole output area row by row, starting from the top to bottom. like Raster CRT, cathode ray tube, that big display device with a back or a television, right? Okay. So the laser printer, those are raster devices. And these devices are good to produce high quality graphics because the high quality comes from pixel by pixel. Each and every pixel is stored in the memory. Each and every pixel has its individual value, color value. Each and every color within the, each and every pixel and their color is represented in the memory. ඒ කියන්නේ හැම ඩොට් එකක් ගානෙම මෙතන විස්තර කරලා තියෙනවා memory එකේ. Raster devices. From top to bottom, left to right. Left to right, top to bottom, all the pixels described in the memory, in the graphic file or the frame. In the video, there's a frame. Therefore, each and every single pixel is defined and can be represented. And those are very good for producing high quality graphics with large number of colors, and the color scale is very large. And it is very easy to display filled areas also. Easy to display filled areas. When we come to the vector devices, these devices produce the graphic display normally by drawing lines and curves, at the appropriate output positions. The necessary output positions, those things are drawn normally. Those are drawn at appropriate output positions. There is no any need of having scanning the whole area of output normally, right? Deepika Sandamali says that she cannot hear. Can you all hear me? Hello? Hello, can you all hear me?
Yes, sir.
Deepika saying that she can't hear. I don't know why. Yeah. So all the people can hear. Deepika, that may be a problem of your speakers, I think. She can't hear no anyhow. Let me message her. That may be problem of your speaker. Deepika Sandamali went off, I think now. Now she's coming. Still she's not here. Still she's not here. She's having, I think, a connection problems. Right. Anyhow. So let's come to vector devices again. Normally these devices produces graphic display or output on the display by drawing lines and curves at the appropriate locations wherever you want. There is no any need of scanning each and every pixel on the screen and display all the pixels. You don't have to fill all the pixels. Only the needed shape and the locations are to be drawn. Like plotters, vector CRT. Do you know what is a vector CRT? Do you can you give me an example for vector CRT? Anyone? Let me know. No one. T also, because otherwise it's unfair to have while you are looking at me. Eh? So you also can have your tea while I'm doing the lecture, no problem. Now, this plotter, I think you may have seen, or if you type plotter, you can see that. Vector CRT also you can see on the Google if you type it. Let me give you an example. In the film, sometimes you may have seen in submarines and the ships, big ships, the radar system is there, right? You can see that radar system shows some kind of dots, and dot is moving, some kind of a, enemy is reaching you. Dot is take type of sound also there, and the dot is coming. Can you remember these type of indicators in the films? Huh? Can you remember? Can you remember such indicators on films? Okay. No, what I can do is actually you can see these type of things. Normally, the outside the pixels or the colors are not there. It's a blank. But the illuminating, only the one dot or line is illuminating. Others are not illuminating. That is what you can see. Right? Only that dot or lines are illuminating, others are not illuminating. So that is what only you can see. Right? So these type of devices we called as kind of vector display devices, and they have limited number of colors normally for display, limited number of colors, and the image size is very small, and difficult to display field areas also. Difficult to display field areas also. So let's see what are the stages available within basic graphic pipeline or graphic display processing. Now let me see. Suppose that we want to display this type of triangle, right? Triangle. Now Dilshani or Dilshani or someone else also can participate now for my discussion. Always, otherwise I am taking Dilshani. Deepika, can you hear now? You can switch on your mic and talk. Deepika, can you hear now? She's not well. Okay, let me take another one. Who has raised that hand with the? Okay, Shehan. Shehan.
Yes, sir.
Shehan.
Yes, sir.
Yeah. You also agreed with the Dilshani earlier because that pixel-based thing, right? Okay, that's why I'm taking you also here. Deepika, can you hear now? Deepika, your voice we cannot hear. Don't know whether she can hear us. Shehan, okay. My question is, now Deepika told that the vector graphics normally represent by the shapes or lines and curves type of things, right?
Yeah.
Okay. Now we are going to draw the vector graphics. Do you know how these the lines and curves or the things are represented? Suppose that I want to have this type of triangle. This is a vector triangle. Now this area, the other areas are blank. Only this white area is drawn by the graphic display device that we call as vector scanning, right? Vector scanning. Now, before doing this vector scanning, we have to keep that vector in the graphic. No, starting point is vector graphics, and the vector graphic is displayed on the screen. To display that vector graphics, that scanning is to happen. Now, do you know how this vector graphic is stored? That is my question.
It's stored in mathematical structure, x-axis and y-axis, calculation in line and path.
Line and arc. What is the way that represented normally? You have learned that thing represented by using mathematical shapes like lines and arcs, right? That is the way you have learned, right?
Yes.
Okay. Now we have to go a little bit further, right? Yes. In the vector graphic representation, the vector graphics once the vector graphic display on the screen, it is a kind of pixels.
Yeah.
You have pixels here. Here also you have pixels.
Yeah.
But when you are storing that vector graphic in the memory, that is the different representation you are using compared to the raster graphic representation. Here you are not going to display anything here in the memory. In the memory, what you say is there is a point 1, 1, 2, 4. Draw a line. Those are commands actually. Draw line. I don't have a board to draw now here. Write things, right? Draw line. Draw line. 2, 4 to, okay, other way we can write 2, 4 to 1, 1. This is one command you have. Another command is there, draw line 2, 4 to 3, 3. Another command there is another command, draw line 3, 3 to 1, 1. Like that you have 3 commands. Like that you have 3 commands. So that will create this type of triangle. Now we say that, now I'm covering that what is the difference between raster graphic and vector graphics also. Now hardware we have discussed. The software or the graphic, what's the difference of the graphics? The difference is happening, difference is available. Once it is displayed there, all are in pixel planes. When you are storing, you are not storing the pixel information here. You are storing only the mathematical algorithms to be used. Line algorithms here. Draw line from here to here. Draw line from here to here. Draw line from here to here. That's what you are storing. Those are some instructions to the computer. Those are some instructions to the computer. Right?
Yes.
Do you understand?
Yes, sir.
Is that clear or not?
Yes. Clear.
Okay. Now in the vector graphics, what we store is actually some mathematical drawing commands. Mathematical drawing commands are stored within the vector graphic. Draw line, draw arc, draw circle, draw what do you call sine curve, or spline curve. There are different mathematical curves available. Those are mathematically defined curves, so we can ask to draw those things, right? So we basically uh, take these lines and curves, and we say to draw them. Right? We say to draw them. We ask to draw them. So then the drawing lines and curves are available here. What to draw and how to draw. And when we go to the representation, when we go to the representation takes and dynamically calculate what are the pixels. Now, for example, draw line from 2, 2, 4 to 1, 1. 2, 4 to 1, 1, draw a line. Now we have to find what are the pixels on this line. Now we have to find what are the pixels on this line. Right? Like that, we have to identify the pixels on these lines. Right? Therefore, next thing is when we are storing the instructions in this way, we don't have to store the pixel by pixel information. The other way, in the raster graphics, store their raster graphic files or the graphic files by describing each and every pixel and their color to be represented on the screen. The bitmap graphic or something. Now, Dilshani told that bitmap graphics are raster graphics. Yes, those are raster graphics. Those graphics are normally stored if it is not uncompressed, or if it is not compressed. If it is compressed, you are not having the pixel by pixel data like that. There's another way. But anyhow, intermediately you have the pixel by pixel data there, right? Intermediately you have the pixel by pixel data. So when you are storing pixel by pixel, each and every pixel in the memory. To store each and every pixel, you need memory. Therefore, the file size is bigger. Vector file size is smaller because you are telling draw like this from here to here, here to here. This curve is to be there. This curve is to be there. This part. Now, for example, suppose that we have to fill some kind of area. Fill the enclosed area. That type of command is there. Fill the enclosed area. Now the filling is happening. Now you don't have to do each and every pixel available within that area. Shading type of things also can be done. Not only one color, many colors also can be possible with the shading. Okay. With that, now we can understand why raster graphic takes a lot of memory. Vector graphic takes smaller memory. For that, we have the arguments. We have arguments for that. Why raster graphic takes a lot of memory and vector graphics takes smaller memory. We have those arguments now. And what's the mechanism they store in the memory also we have discussed. Already we have discussed that basic graphic element or the building block of computer graphics starting from picture element or pixel. That is picture element or pixel. That is the basic component of raster graphics. When we compare the raster graphics and vector graphics, raster graphics image is represented by grid of pixels. Raster graphic pixels are grid of pixels like that. Each and every pixel is different from the other. You can see some pixels enlarge here and see. Therefore, you can see in the raster graphics more details, more information available because one pixel is different from the other. Their colors are represented individually. හැම ඩොට් එකක්ම වෙනම ස්ටෝර් කරලා තියෙනවා ඒගොල්ලන්ගේ මෙමරි එකේ. Therefore, lot of information available and detailed. Vector graphics are not detailed. They are giving the rough shapes and their representation, rough idea will be given. The color intensity of each pixel is recorded individually here in the raster graphics. Therefore, that need lot of memory. Vector graphics, on the other hand, the image is described as series of lines and shapes. Now we know how it will be represented. Those are set of instructions to draw something on the screen. Vector graphics store some instructions to draw something on the screen. So the line art or computer design software is using these type of things and need less memory. Now the same fashion, this display devices also can be separated, raster and vector. The monitor, raster graphics and number of pixels and their resolutions are there. Now there is another property available within raster graphics and vector graphics. Later I will tell you that property. Who can remember that property? When you compare raster graphics and vector graphics, normally you say that one as that one in that manner. What is that property? I have talked about two properties. One is their storage less and high, that size is less and high. The other one is shapes are used and pixel by pixel information is stored. That's the other thing. I have given scientifically how those are happening. There's another thing you normally take. When you are comparing vector graphics and raster graphics, it's one of the popular things. There are many differences. Anyone? Fatima or anyone? Dilshani? උත්තරයක් තියෙනවද හිරුනි? මදුෂ? මදුෂ? මොකක්ද අපි කතා නොකරපු එක මෙතන? Which one we have not discussed?
Color.
Color. What's the now you can talk and everything, right? Okay, good. Deepika, what is the color problem? Can you a little bit explain about it? Deepika.
But I don't know, sir.
No, it's okay. You are a student here. No? The student is to learn things, right? So you are coming here to learn. Therefore, you are telling something what you know, what you understood. Then we cannot discuss. Okay, tell what's the problem of color? Normally, we say that a large number of colors are available within the raster graphics, but not in the vector graphics, right? Is that what you are saying?
Yes, sir.
Yes, but here in the vector graphics also, we can have large number of colors, but it's very difficult to store. It's very difficult to store because we are not keeping lot of details. If you are going to have large number of colors and large number of pixels to be available in the memory with vector format, then again it will become a raster format type of thing. හැම dot එකක්ම වගේ detail කරන්න වෙනවනේ එහෙමනම්. එතකොට අර ඒක නිකම්ම raster වෙලා. It's no point of keeping as a vector. Sometimes you can keep less memory when you keep it in a raster than vector. Okay. Now there's one more big argument which you normally consider in the diploma levels when we are comparing raster graphics and vector graphics. What is missing here? Dilshani, are you there?
Sir,
Oh yes. You told it. That's why I'm asking.
is that about resolution dependency?
Ah, right. You can remember, right? That's good. Thank you. Which one is resolution dependent and which one is resolution independent?
Raster graphic is resolution dependent and vector graphic is resolution independent.
What is the meaning of it?
Resolution dependent means the pixels per inch.
Pixels per inch is resolution dependent. Then vector graphics, I cannot relate it. What is the DPI and the resolution independent and dependent? Is that the meaning?
I don't know, sir, that much about that.
You have done some kind of memorizing things, right? To give, like parrots. You have to understand the things. Try to understand what it is. Always argue what it is. Then you will get the knowledge about it. Then that will retain in your memory. Anyone else who can answer this question? What is resolution? Now, thank you for your answer, Dilshani. Actually, resolution independent and resolution dependent. Normally, we say that raster graphics are resolution dependent and vector graphics are resolution independent. What is that? What's the meaning of it? No one knows. Okay, let me tell you that. When you have a graphic, right? When you have a graphic, suppose that is a raster graphic. That raster graphic is coming with number of pixels, right? Because we know that each and every dot is defined in the memory. Each and every dot is defined in the memory. Okay, how many, what is the length, what is the height is available. That number of pixels are defined one by one in the memory. Assume that you have 5 by 10, 10 width, 5 height. Graphic is available. 10 pixel, 5 pixels. Now, when you show, when you display it, 10 pixels and 5 pixels, it will be covered. What happens if you stretch it to 20 type of area? What will happen if you expand it to 20 or 50 by 50 area? Now look at this one. Now we have taken a very small area from here and make it bigger area. What has happened? මොකද්ද වෙලා තියෙන්නේ මෙතන?
Sir, can you please speak Sinhala?
Tell it in Sinhala.
Yeah.
මම අහන්නේ දැන් මෙන්න මෙතන මේ පොඩි කෑල්ලනේ මම අරගෙන තියෙන්නේ. මේ පොඩි පොට්ටුවේ තියෙන කෑල්ල තමයි මෙතන මම ලොකු කරලා තියෙන්නේ. මොකද්ද වෙලා තියෙන්නේ එතකොට?
පොඩි කොටසක් අරගෙන ලොකු කරද්දී ඒක යන පික්සල් ප්‍රමාණය නිසා බොඳ වෙලා පේනවා.
පික්සල් ප්‍රමාණය කියන්නේ මොකද්ද? That area contains only a limited amount of pixels. That will not change, right? That will not change. Understood? So the same number of dots will be generated on the screen. අපි 5යි 10යි 5වරක් 10යි 50යිනේ. ඒ පික්සල් 50 තමයි පික්සල් 1000ක ඇන්දත් පික්සල් 50යි පැඳින්න පුළුවන්. එතකොට මොකද්ද වෙන්නේ? අර 1000 බෙදනවා 5යි 10ට වෙන කරලා කොටු වලට දානවා. එතකොට අර පික්සල් ලොකු ප්‍රමාණයක් එක කලයකින් පෙන්වනවා. Do you understand what I'm saying? Okay. Assume that we have here in the memory we have definition for 2 by 3 2 by 3 pixel area. මෙතන pixel කීයක් තියෙනවද? 6යි. When we put it into this type of screen, suppose that we have small area like this, 2 by 3 area is there. This 2 by 3 area, we fill these pixels, right? This 2 by 3 area, we fill these pixels. And now this is available within the 2 by 3 area, right? This is available within the 2 by 3 area. And this 2 by 3 area, we are going to expand. We are going to display it on full area like this. But still we have only how many colors? 6 colors available, right? Still we have only 6 colors. Now in that situation, maybe a number of pixels, like this type of number of pixels, are to be displayed as 1 pixel. Pixel 4ක් එක pixel එකක් හැටියට වගේ පෙන්වන්න වෙනවා. Right? Because in the definition, when we are defining the graphic, we have only this number of colors and the pixels. So that even the area is bigger with number of pixels, the blocks are limited, therefore the number of blocks are becoming larger. Right? That is what we are saying here. Right? So in the raster graphics, what we can see is that the resolution or the spatial resolution of that for that particular thing we called as spatial resolution. That is with respect to the space. The spatial resolution limitation is available within the raster graphics because we are defining a number of dots there. Those are the dots and their colors and the memory available. Even the size is getting bigger, those dots will be replaced in the bigger manner. Then you are getting unpleasant representation like this. Unpleasant representation like this. Bigger dots are coming. Bigger pixels are coming. Because one color dot is covering number of pixels. එක color dot එකකින් pixel විශාල ප්‍රමාණයක් cover කරලා තමයි දාන්නේ. Right? That is how the pixel view is coming. Okay, clear? Is that clear and understood? Yes or no?
Yes, sir.
Right. Now,
Yes, sir.
now next one is when we come to the vector graphics, When you come to the vector graphics, that is not the case, right? When you come to vector graphics, that is not the case. In vector graphics, you have definition to draw something. Now suppose I have drawn line from here to here. Next time you are expanding this one, little bit here and little bit here. In such situation, the graphic will become this size. In such situation, again this new dot is moving to somewhere here, and other dot is going to somewhere here. Now there are two dots available. New dot is available here. The other dot is available here. Now there are two dots available. Again you are drawing line, but that line you are recalculating. You have to recalculate that. Your processor, graphic processor, will recalculate the pixels among this line and redraw it. Therefore, you are not replacing, because the pixel information is not available there in the memory. Only you have the algorithm what you have to use. මොකද්ද අන්දිය යුත්තේ කියලා shape එකේ ස්වභාවය තියෙන්නේ. ඒකට ක්‍රමවේදය තියෙන්නේ. ක්‍රමවේදය තියෙන්නේ මොකක්ද දැන් දෙන්න. රේඛාවක් අඳින්න නැත්නම් circle එකක් අඳින්න, ඒ කියන්නේ රවුමක් අඳින්න. So that type of instructions are there. Therefore, if you are going to change the shape for the locations, that will automatically recalculate what are, because see, earlier also the pixels were calculated. Now also when you expand it, again that pixels will be calculated and redrawn. Therefore, you are not getting any effects like earlier. Do you understand it? Yes or no? Yes or no? තේරුණාද නැද්ද?
Yes, sir.
Yes, sir.
Krishani, anything? No, okay. Right. So that is one of the major things you have to understand and keep in your memory. Now we have discussed what is this resolution independent and resolution dependent. Raster graphics depends on the resolution or the spatial resolution, number of pixels. Vector graphics are not depending on the number of pixels, because we are not defining number of pixels in the graphic. When we display only, we are calculating them, right? So that type of differences are there. Now here we can see some of the properties of these graphics. These are some display devices and they are standard spatial resolution, VGA, video graphic accelerator device. You normally have got 614 to 480 type of spatial resolution. Super VGA, video graphic accelerator, 800 into 600 or 1024 into 766 type of resolutions are there. When you go to the color depth, when you go to the color depth, so the color depth, sometimes it may be 1 bit color depth. 1 bit color depth. In 1 bit color depth means, now let me discuss what is color depth, because this is also another very important information you have to keep in your heart throughout this particular course. The color depth is a kind of a parameter we use in computer graphics to show the number of colors possible within the graphic. How many number of colors are possible within the graphic? will be represented by using this information called color depth. Right? Now, when we come to the super VGA, right, SVGA, so the color depth can be defined as maybe 24 bits. VGA also same, 24 bits. 24 bits means one pixel is represented by using 24 bits. Now, there is one more thing to be understood here. When we are representing graphics on the screen, or graphics in a file, graphic on the screen or graphic in the file, we have to store the location of the pixel and the color of the pixel. Those are the only two things you have to store. What are the two things? Location of the pixel and the color of the pixel. In the raster graphic, the location is static, not changing, because pixel on a location is not changing. Row by row, column by column, those values are there. Therefore, we can give the location by the row and column in the Cartesian plane. Row number and the column number, by using row number and the column number, you can represent the location. Row number and the column number, you can represent the location. Right? When we go to the color depth, within this location, how many different colors can be represented? That's what we have to understand. Now, for a picture in a file, we know the defaultly we give the row number and the column number. Normally, row number and column number can be given as X comma Y in the Cartesian plane. What is Cartesian plane? මොකද Cartesian plane එක කියන්නේ? ඔයාලා mathematics උත් පොඩ්ඩක් කරානේ මෙහෙදී. What is Cartesian plane? What is Cartesian plane? You have learned this thing in grade 6 or 7. It's a ලොකු මේකක් නෙවෙයි.
X-axis and Y-axis.
X-axis and Y-axis කියන එක කිව්වොත්, if you tell that one, there are so many X-axis and Y-axis. What is this Cartesian plane means? In Sinhala?
There are two perpendicular lines. The horizontal one is the X and the vertical one is the Y.
Yes, that is how you are drawing it, no? Cartesian plane. What is මොකද්ද කියන්නේ Cartesian plane එක කියන එකට සිංහලෙන්?
කාටසිය තලය. කාටසිය තලය. කාටසිය තලය.
කාටසියනු තලය. ඒක අපිට තව වචනයක් කියනවා. කාටසියානු ඛණ්ඩාංක තලය.
ඛණ්ඩාංක තලය.
How do you call a point in that one?
ලක්ෂය.
ලක්ෂයට මොකද්ද කොහොමද කියන්නේ? අපි ඒක මෙහෙම x, y කියලා ලියුවට පස්සේ මොකද්ද කියන්නේ ඒකට?
ඒ ඛණ්ඩාංක ලියන්නේ.
ඛණ්ඩාංකයක් කියලා කියනවා, right? That we called as kind of a point location, right? Cartesian location, right? Cartesian location. A pair will be given as horizontal and vertical, or the column number and row number. This one is x-axis, as she said, this is y-axis, and x value will be taken from this one, y value will be taken from this one, right? So x and y value can be taken and give the location x comma y. So the pixels also having these locations. Locations are default on the screen, because those are not changed. But the colors are changing within the location. So the color is to be stored within the memory. We are storing only the color value. Now, when we are storing that color value, how many different color values can be there? That is the thing we are going to discuss. ඒ කියන්නේ එක පික්සල් එකකට ගත හැකි විවිධාකාර වූ වර්ණ ප්‍රමාණය කීයද කියන එක. The color depth is how many number of colors are possible to take by one pixel in that particular graphic. If you talk about the color depth of any particular file, that represent how, if you take any pixel from that graphic, how many different colors can be taken by that particular pixel. That is the color depth. Now, for the color depth, there are different other terms also we can use. Another term we called as color resolution. Color resolution. How many different colors are possible? Color resolution. Color depth. Sometimes we called as bit depth also. And there's another term we called as chromatic resolution. Chromatic resolution. Color resolution, chromatic resolution, or color depth. The same thing for a given file. Now let's see whether if it is if that color depth is 1 bit. If the color depth is 1 bit, if you are having 1 bit color depth, right? If you are having 1 bit color depth, how many different colors are possible per pixel? How many possible colors are per pixel available? 1 bit means how many states are available?
1 and 0.
1 and 0. Then how many states?
2 states.
2 states are there. Right? 2 states. 1 and 0. So if you have 8 bits,
0 to 7.
0 to
7.
7.
Yeah.
So I'm asking 8 bits. 1 bit means 0 and 1, therefore 2 states, right? 8 bits.
I think 0 to 7. Then 8 bits.
The number of bits are 8. How many, now that has to be considered as how many different numbers can be stored within that particular 8 bits. 8 bits are 2, that is in the memory. 8 bits are in the memory. You can store different numbers by using 8 bits. How many different numbers you can represent by using 8 bits? That is normally 2 to the power 8. How much is it? 256.
256.
If there are 2 bits, how many different colors?
4 bits.
4 colors.
4 colors.
4 colors. 0, 0, 0, 1, 1, 0, 1, 1. Is that clear and understood? Yes or no?
Yes, sir.
Everyone?
Yes, sir.
So the color depth is how many number of bits
Yes, sir.
allocated per pixel to store in the memory. uncompressed manner, right? Uncompressed manner. Yeah, I'm talking about uncompressed manner. Compression ගැන කතා කරන්නේ. Okay? Is that clear?
Yes, sir.
Okay. So, based on the number of bits you are allocating per pixel, the colors which are possible per pixels are going to be different. How many number of colors are possible per pixels are going to be different. So these possibilities are coming from different point of views, right? These different pixels are coming from different point of view. That can come through what you call based on number of bits, and that will influence on how much of memory needed to store that graphic also. Now there are things you have to balance. When you allocate number of bits per pixel, and if the graphic has number of pixels, the memory needed to store that graphic in the raster fashion decided by number of pixels as well as number of colors possible per pixel, or the number of bits allocated per pixel, right? So there are some other techniques available, color lookup table based mechanisms. We will discuss about color lookup table later. So the spatial resolution, or the spatial what do you call pixels available, number of pixels available, that can be given as DPI, dots per inch. Per 1 square inch, how many dots are available? And scanners sometimes use 1200 DPI, that's very high resolution. High spatial resolution will be given. Printer sometimes takes only 300 to 1200. So these type of DPIs are dots per inch available. That means how many dots are generated per 1 square pixel, square inch. Spectral resolution is another one. The spectral, I have discussed about spectral resolution, number of colors available, specific wavelength intervals in electromagnetic spectrum that sensor can record. We call as spectral resolution. We will go to the spectral representation also later in the computer graphic colors, right? When we discuss about colors, computer colors, we will come to this one. Pixel resolution or spatial resolution is normally represented by using number of pixels length and height. Now, next topic is a very important topic, color lookup table. Now let me come to this lookup table in this way. I told you the pixel in the raster graphics, to store one pixel, we need a number of bits. That is the definition of color depth or bit depth. Assume that we have allocated 8 bits, or in the full color or RGB full color or true color. RGB true color, we use 24 bits. 24 bits. 24 bits means how many colors are there? RGB true color, you have 24 bits. එක pixel එකක් bits 24ක හැම pixel එකක්ම represent කරන්න in the memory. When you represent it by using 24 bits, how many colors are there? How many colors are there?
4 to the power 24.
2 to the power 24. That is about 16.7 millions. Right? That is about 16.7 million colors are available. Different colors are available. right? 16.7 million different colors are available. Now, when you consider about this 16.7 million type of colors, large color numbers, right? 24 bits means 3 bytes per pixel. You have to allocate 3 bytes per pixel. 8 bits means 1 byte. 3 bytes are available per pixel. Okay. Suppose that you have 100 pixels. 100 pixels in an image. 10 by 10 or something. Here 10, here 10, 100 pixels available. How many bytes are there then? If it is RGB true color image, what is the capacity of this file? What is the file size? 10 by 10 pixels available, that means 100 pixels in the image. This is RGB true color image. That means the bit depth is 24 bits. That means 1 pixel is 3 bytes. What is the capacity? What is the capacity?
800 bytes.
800.
300 bytes.
300 bytes, yes. Because 1 pixel is 3 bytes. This is equivalent to 3 bytes. This is bits, no? Right? This is 3 bytes. 1 pixel is 3 bytes. When you have 3 bytes, 1 pixel, 100 pixels are there. Then 100 into 3, 300. Do you understand now? Capacity is 300 bytes. Okay? Understood, yes or no?
Yes, sir.
Okay. Now, think about this. 24 bits are allocated. How many possible colors available? How many possibilities available for the color? 16.7 million. 16.7 million. But when you take any image, most of the images, cartoonish images like things, right? When you take most of the very less number of color-based images, in that situation, you are having most of the time, the available colors within that image may be less than 256. Do you understand what I'm saying? In the image, there are colors available, no? Those colors can be categorized into maybe less than 200 colors. Even though the possibility for available for 16.7 million, only maybe 100 or 200 colors available within the image, not this one, but here you have only 100 pixels, no? If you each and every pixel is different from each other, you have only 100 colors. මේකේ පික්සල් 100යිනේ තියෙන්නේ. ඒ හින්දා මේක එකින් එකට වෙනස් පික්සල් ගානක් තිබුණත් color 100යි. Forget about that. There are many cases in the images you have only few colors available, less than 200 or 256. Therefore, allocating each and every pixel with 3 bytes is a waste. Why I am telling that? Because full 16.7 million colors are not available within that image. Therefore, what we can do is, we can have a table, small table, and we create an index. We create an index here. We have index here. And here we have color. Index and color. Index represent 0, 1, 2, dot, dot, and n number of colors. And the real color, maybe 200, suppose last one is 200. The real color is represented as 24-bit color here. This is the original color. Those are different one to another. Dot, dot. Those are real colors. Now we table all the colors available within the image in a table. The actual color number is there, but we know that number of colors are less. Therefore, we are giving index, new color number for that particular color. A color එකට අලුත් number එකක් දෙනවා index එක. color එක මේ පැත්තේ තියෙනවා. Then what we do is, we do not store in the image, we are not storing this particular color, because to store that color you need 3 bytes. Instead of that, here if it is less than 200, you can store these numbers by within 8 bits. තේරුණාද මම කියන එක? එතකොට අර ඉන්ඩෙක්ස් එක අපි ස්ටෝර් කරොත් වෙන්නේ මොකද්ද? ඉන්ඩෙක්ස් එක ස්ටෝර් කරන්න නම් අපිට බයිට් 3ක් ඕනේ නැහැ. එක බයිට් එකක් උලන් 8 bits is enough, because that is less than 256. 1 byte is enough to store that particular type of pixel. But other than that, you have to store this table also. So this way of storing we called as color lookup table. This one we called as color lookup table. The color is coming before this one. Lookup table or color lookup table. CLUT. CLUT. Color lookup table or lookup table. So we store the lookup table and the lookup table indexes in the pixel, each and every pixel. But when we are showing the color, the index is the one we are getting here. Index may be 507. So that 507 will be referred here, and that color comes and replace here. That's how it is happening on the display. Right? That's what's happening in the lookup table base or color lookup table based method of storing images or the representation of the images. Normally these type of file formats we called as index file formats. We call them as index file formats. Okay? Is that clear and understood? Is that clear and understood? Yes or no? Is that clear and understood? Yes or no?
No, sir.
No.
Yes, sir.
Okay, let me tell you again. Now in the full length of colors, right? Full length of colors, we have 24 bits allocated for each and every pixel. හැම pixel එකටම අපි byte 3 ගානේ true color එක තියෙන එකක් දුන්නොත් that pixel can take up to 16.7 million colors, right? Roughly. But when you take a small picture, sometimes, most of the time, that picture contains less than 200 or 256 for 50 colors. Yeah, right?
Yeah.
Most of the time, that picture may contain less than 200 or 256 colors. Do you understand that? Right?
Yes, sir.
Okay. Now, therefore, that if there are number of colors less than 200, suppose that maximum is 200, then how many bytes need to store this 1 to 0, 1 to 200 numbers? It's about 8 bits. Ne?
8 bits.
8 bits means you can go to 0 to 255 ne? You can store numbers from 0 to 255 within 8 bits.
Yeah, yeah.
Is that clear?
Yes, sir.
Right? So we are wasting other bits, no?
Hmm.
So, but the real color number is a big one, right? Real color number is a big one, but according to the different colors, less than 200. Therefore, we put all these different colors with their real color number in this column, and we count them from 0 to something. Suppose that 200. Okay. Now,
Okay.
earlier we have stored this full length of color number in the memory. Now we are not going to do that. What we are going to do is for the same color, we put the index in the location.
ඒ කියන්නේ සර් මෙහෙමයි දැන් ඉන්ඩෙක්ස් එකේ බිංදුව ඉඳන් 1 2 3 තියලා තියෙනවා. ඒ බිංදුවට අදාළ කලර් එක අපි දානවා හිතමු බිංදුව කියන්නේ සුදු කියලා. ඒ white ඊට පස්සේ 1 නම් black
white තියලා තැනට අපි අර බිංදු 24ක් තියෙන එක නෙවෙයි දාන්නේ. අර ඉන්ඩෙක්ස් එකේ තියෙන බිංදුව දානවා බිංදු 8ක්. හරිද? මේකත් බිංදුවයි මේකත් බිංදුව නා. හිතන්න මේකේ තියෙන්නේ ලක්ෂ ගාණක් කියලා. නමුත් මෙතන නම්බර 1. එතකොට ඊළඟ කලයක මේ ඒක නම් දැන් මේ හරිය තියෙනවා කියලා හිතන්නේ මේ කලයක. මෙතන තියෙනවා නම් එතකොට මෙතන තියෙන්නේ මේක හිතන්න මේ කහ වර්ණය කියලා. ලා කහ කියලා ලා කහ කියන්නේ 1. අපි දානවා 1 මෙතනට. මේක දාන්නේ නැහැ. right? නමුත් මේක ටේබල් එකත් අපි ස්ටෝර් කරනවා ඉමේජ් එකත් එක්ක. එතකොට යම් කිසි කෙනෙක් මේක බලනකොට මේ ස්ක්‍රීන් එකේදී මේ මෙතන තියෙන 1. එතකොට මෙතන 1 බයිට් එකනේ අපි දීලා තියෙන්නේ. මොකද සමහරට 200 වෙන්නත් පුළුවන් තියෙන්නේ. හරි? එතකොට 1 බයිට් එකකින් ඕක ස්ටෝර් කරගන්න පුළුවන් ඒක. බිංදුව 255 දක්වා නම්බර ස්ටෝර් කරන්න පුළුවන් බයිට් එකකදී. right? එතකොට මෙතන 1 තිබුණාට පස්සේ 1 කියන්නේ මොකක්ද කියලා බලන්න අපි මෙතනට එනවා. 1 කියන්නේ මේක. මේකේ තියෙන කලර් එක මේකේ කියලා. ඊට පස්සේ ඒ කලර් එක ගියලා මෙතනට දානවා පික්සල් එක. මේක හරියට ඩික්ෂනරි එකක් වගේ එකක් තමයි අපි මේ යවන්නේ. To refer and get the color, right? But we are reducing the memory space needed. Okay?
Okay.
Now, in this case, we have earlier allocated 3 bytes per pixel. Now 1 byte per pixel. What is the memory capacity then? 100 pixel. With the color lookup table, 1 byte into 100 bytes. Plus, the table has to store. Table capacity has to bear by this one. Is that clear and understood now? Yes or no? ඉස්සෙල්ලා table එකක් store කරන්න ඕනේ නැහනේ. Now you have to store the table as well in the memory. Is that clear? Yes or no?
Yes, sir.
Everyone? Okay. What about Dilshani?
Yes, sir.
Okay. Kishani?
Yes, sir.
ඒකේ සර් මේ මොනවද 100 කියලා ගත්තේ මොකද පික්සල්ස් තියෙන 100යිනේ. ඒතර අපේ 100 විතර අපිට අදාළ වෙන්නේ. ඒ නිසා තමයි
100 විතරයි.
ඔව්
100යි නමුත් එක පික්සල් එකක් ස්ටෝර් වෙන්නේ එක බයිට් එකක කියලා මෙතනින් ගන්න පුළුවන්.
හරි සර්.
පැහැදිලිද?
ඔව් සර්.
Have you seen this color lookup table in the computer graphics software? Photoshop or somewhere? No. When I go to Photoshop, I'll show you this color lookup table, right? Okay. Next day. Or whichever day I'm going to demonstrate the Photoshop, I will show you that one. Okay. Is that clear?
Okay, sir.
මේ color lookup table කියන දේවල් තියෙනවා Photoshop එතකොට Corel Draw හැම එකේම බලන්න පුළුවන්. ඒ image එකේ තියෙන color lookup table එක මොකක් හරි index file format එකකින් save කරනවා. So GIF file format is index file format. And also
hexadecimal
PNG
number
also
එකෙන්
there,
තියෙන්නේ
PNG. Huh?
hexadecimal number එකකින් තියෙන්නේ color code එක ඒකද?
hexadecimal එකෙන් තමයි color code එක තියෙන්නේ. නමුත් color code එක memory store කරන්න නැතුව index එක store කරන්න පුළුවන්. table එකේ color එක තියාගෙන. එතකොට pixel ප්‍රමාණය වැඩිනේ index එකට වැඩි. එතකොට අර repeat වෙලා තියෙනවා නම් එකම color එක අර index එක විතර store කරලා memory එක අවශ්‍ය ප්‍රමාණය අඩු කරගන්න පුළුවන්.
ඒතර memory එකට යන ඉඩ ප්‍රමාණය අඩුයි. RAM එක කරන wastage එක අඩුයි.
That is the reason for having this color lookup table in some of the file formats, GIF and PNG index file format, and there are some other index file formats available like in this, tag image file format, right? Tag image file format. So those type of file formats, you have these indexes, right? Okay.
Okay, sir.
Is that clear?
Yes, sir.
So we'll do in that way, right? Okay. Okay, I'll stop here today and let's continue from there next way with raster graphics and vector graphics you can go through. I don't have mechanism to put these notes onto the Moodle because I asked them to create a Moodle account for you all and give me. So I hopefully by next week we don't have class, right? Okay.
Okay, sir.
Next week means just after the New Year holiday, right? Okay. So next Thursday we are not going to have the class, but a week after we are going to have the class. On that day we can see continue from here. By that time they may create the Moodle account, right? Okay. Any other questions up here then, right? We'll meet after the new year, right? So wish you all happy new year. Okay.
Happy New Year, sir.
Happy New Year.
Okay, sir. Thank you, sir.
Thank you.
Happy New Year, sir.